Welcome back to the deep dive. We often talk about how the best knowledge really lives at the intersection of unexpected ideas.
It really does.
And today, we're embarking on a deep dive that physically links two worlds that, they rarely even share shelf space.
Yeah.
A high-tech software blog and the humble spice aisle.
That's absolutely right. Our sources for this are really unique. We're tracking this methodical journey that transforms a simple culinary discovery, a package of mixed seeds, into a genuine botanical project.
Okay.
So our mission is really to unpack how curiosity, especially when it's paired with modern tools like AI, can turn something you'd find in any kitchen to this long-running scientific endeavor.
And the star of this particular experiment is Panch Phoron, sometimes known as Indian five-spice. You'd probably recognize the smell if you've had Eastern Indian or Bangladeshi food. It's not that powdered blend people think of, like Chinese five-spice. This is a mix of 5 very distinct whole seeds.
And that's the key.
And the fact that they're whole, totally unprocessed, that is the absolute core mystery that kicked this whole thing off.
Yeah, that whole versus ground difference is so critical. When you buy ground spices, you're basically buying a dead ingredient, It's ready for immediate use.
Sure.
But when you buy whole seeds, especially from, say, an international market, you are potentially buying life.
Yeah.
The question we're immediately hit with is just how much potential for growth is hidden right there in your pantry.
Okay, so let's unpack that starting point. The author of our source material, he wasn't even looking for seeds. He was hunting for pastes, maybe sauces.
Right.
And he just stumbles on this bag of mixed seeds. The reaction he describes is that classic learner's instinct. Okay, I recognize some of these, but what's the whole composition? What's it for?
And what's fascinating here is just the sheer speed of modern knowledge. Historically, identifying a blend like this would require deep culinary knowledge or, hours of cross-referencing botanical guides.
Days, maybe.
Maybe days, yeah. The author, driven by that sort of tech-focused mindset, just used AI to identify the contents of the package immediately.
That's the real shift in how we learn now, isn't it? Curiosity plus technology just gives you this instantaneous launchpad. It wasn't just about getting the name Panch Phoron. It was getting the precise breakdown.
Which is essential for any kind of methodical experiment.
Exactly.
And that confirmation, coupled with the realization that these were whole seeds, it immediately posed the key scientific question: are they viable?
Right.
Most commercial seeds, whether for us to eat or for animal feed, they go through some kind of processing, heat treatment, sterilization, even irradiation, specifically to stop germination.
So really the default assumption should be that they won't grow.
Exactly. That low expectation is what makes this so significant. If a commercial packet of seeds just sitting on a grocery shelf still has viability, it suggests a much lower level of processing than is typical.
It turns a simple ingredient into a living specimen ready for a project.
It does.
And this takeaway is key for you, the learner. Your kitchen, your pantry suddenly becomes a potential laboratory. That boundary between a consumable and a biological system, it just dissolves when you combine that flash of curiosity with a tool like AI.
Right. And that move from what is this to can I make it grow? That's a perfect example of applying a systematic, research-driven approach to an everyday thing.
So now we have to drill down into the beautiful complexity of this blend. Panch Phoron isn't just a random handful of spices. It's a very carefully measured, visually distinct combination.
It is.
We really should walk through the 5 components because visualizing them is key to understanding why identification, even for an AI, is so specific.
Absolutely. The AI analysis helped the author catalog these by their precise morphology, their shape, their size, color, texture. If you were to dump a small pile of this on a white plate, the visual differences would be just striking.
Okay, so let's start with the largest ones, the most visually dominant pieces in the mix. What would we see first?
Those are the fennel seeds. They're the largest in the mix, easily recognized by their light green to sort of pale yellow-green color. Their shape is a pronounced, ridged oval, almost like tiny canoes.
And they have that licorice-like aroma.
That's the one, that recognizable, sweet, licorice-like smell.
And then, contrasting with the fennel, you have cumin.
Right, the cumin seeds. They're also elongated, like fennel, but they're visibly smaller, thinner, and more of a brownish yellow. They also have ridges, but they're much finer, more defined than on the fennel. If fennel is robust, cumin is slender.
And that's the earthy, smoky flavor.
Exactly, the base note for the whole profile.
Okay, the next seed is my favorite in terms of just its geometry. It looks nothing like the first two.
You're definitely talking about the fenugreek seeds. They truly stand out. Their color is this warm, yellowish amber, almost like miniature polished stones.
They look like little rocks.
They do.
Oh,
And crucially, their shape is angular and blocky. They aren't rounded or oval at all. They have corners, irregular facets, which makes them instantly recognizable.
so we've covered the three largest. Now we get to the two smallest, darkest elements. This is where I think people often get confused. The details really matter here.
They do. First, we have the nigella seeds, which the source specifically notes are also known as kalanji.
Kalanji, right?
These are small, matte black, and they're often described as teardrop-shaped or highly irregular. They have a slightly porous texture and almost grainy appearance. They add that pungent, almost oniony depth when you cook them.
And finally, the tiny little powerhouses, the ones that deliver that sharp kick.
That would be the brown or black mustard seeds. They are the absolute smallest component in the entire blend. What distinguishes them from nigella is their almost perfectly spherical shape,
Oh, interesting.
and their color is a dark reddish-brown to near black. Their size and that round geometry, it just confirms they're a completely separate species from the angular fenugreek or the teardrop nigella.
The variety is just incredible. I mean, it's a complete spectrum of botanical architecture right there in one spoonful. From the ridged ovals of the fennel to the angular block of fenugreek.
To the contrast between the teardrop nigella and the perfectly round mustard. Yes.
This rigorous observation of morphology, it's exactly what a systematic thinker, like a software engineer, would use to categorize and manage data. It's all about classification.
That's the link. You move from visual ID to categorization, and once it's categorized, you can hypothesize about their function, both in the kitchen and in the garden. And since they are whole, we move immediately to testing that hypothesis.
So thanks to the AI and some keen observation, we know what we have. Now for the big question. How do we test if they can still grow? The hypothesis was that since they were whole, a significant percentage should still be viable.
And this is where that systems thinking really comes in. A typical gardener, they might meticulously check viability first. The author actually details what they skipped. The common low-stakes, damp paper towel test.
Wait, why skip the paper towel test? Isn't that the standard low-risk way to avoid wasting soil and time?
It is standard, but skipping it suggests a prioritization of, well, efficiency and scale. The paper towel test is a localized, small-scale test. It gives you proof of life, but it doesn't tell you how well they'll perform in actual soil.
I see.
So instead, the author chose the scatter method, sowing the seeds directly, just broadcasting them over the surface of a germination pot.
That sounds like the gardening equivalent of a production push, not a sandbox test.
That's a great way to put it. It's a risky but very efficient approach. It implies a broad, iterative strategy. You're testing the whole system at once. The soil, the microclimate of the pot, and the viability of all 5 seeds together.
And the success rate across 5 different species in one pot is going to be incredibly varied, right?
Oh, absolutely.
Yeah.
You wouldn't expect 100% germination for all 5, especially given the differing needs of, say, mustard versus fenugreek.
But the scatter method, it promises a wild, mixed, and fragrant result if it works.
And that leads to the anticipated result. It's not just about getting ingredients, it's about the sensory transformation of the space. It's not just about harvesting seeds, it's about the environmental payoff.
So the goal is twofold.
Precisely. A source for fresh culinary material and the creation of a lovely aromatic scent in the garden. Imagine walking past that patch and getting that complex, layered fragrance of all 5 spices growing together.
It turns a successful experiment into a real aesthetic benefit.
It integrates the research project into the simple joy of home improvement.
Now we come to the part that really, I think, validates you, the multifaceted learner. We have to look at the source itself. This detailed account of seed morphology and gardening didn't come from a botany journal.
Not at all. It was posted on a blog titled kionmeng.org, Musings of an Old Software Plumber.
That title alone is just a key identifier of the perpetual learner. It's not just an expert in one field dabbling in another. It's someone who applies the core philosophy of their profession systems thinking, debugging, rigorous documentation to every curiosity they have.
Let's break down that professional background because it provides the structure for this entire deep dive. The author is clearly deep into high-level, complex technical work. They focus on free and open source software, or FlowSS. For you, the listener, that means they're immersed in collaborative, transparent, and often highly abstract programming languages like Elixir, Erlang, Haskell, Python, Rust, and Go.
That's a highly analytical, almost mathematical skill set. So what does debugging a complex distributed system have to do with whether a mustard seed sprouts in potting soil?
Everything. The connection is in the transferable skill set. Think about what a software plumber does. They analyze systems, they identify dependencies, they predict failures, and they iterate on solutions based on meticulous observation.
So the garden just becomes another system to be analyzed and optimized.
Exactly. When you're developing code in an open source environment, documentation is key. You track every change, every variable, every outcome. Now look at this source material. It's titled Notes on Gardening, Part 770.
Part
770. This isn't a casual weekend hobby. This is a massive, ongoing, highly documented project.
That implies a level of dedication and structured tracking that most home gardeners would never even approach. It suggests a database of failures, of successes, of methodologies.
That methodical documentation is the bridge. In programming, if your code fails, you trace the input variables. In gardening, if your seed fails to sprout, you trace the variables, the soil, the water, the light, the quality of the seed itself. The technical mindset provides the rigor to turn casual planting into a systematic experiment.
It's the application of systems analysis to a natural ecosystem. They're just planting. They're creating a verifiable, iterative experiment, much like you would constantly refine an open-source software project. The code in this case is just the environmental condition.
And that breadth of interest, fish keeping, photography, dieting, home improvement, meditation, all alongside cutting-edge programming, it just shows a restless, disciplined intellect.
I think it really validates the listener's own tendency to use their primary skills, whether it's research or analysis or technical synthesis, to master completely new disciplines.
This gardening project is just a natural extension of that research methodology.
It's such a powerful lesson in how to learn. You don't have to compartmentalize your skills. The analytical tools you use to break down a complex programming language are the exact same tools you use to distinguish a nigella seed from a mustard seed and to design an efficient germination test.
The boundaries between expert and novice, they truly dissolve when you apply that high-level intellectual rigor to something new.
What an unexpected and layered journey this has been. I mean, we moved from a chance encounter with a grocery store product, used AI for instant identification, meticulously analyzed the distinct traits of fennel, cumin, fenugreek, nigella, and mustard.
And followed that curiosity into a dedicated gardening experiment applying the very efficient scatter method.
The overwhelming takeaway here, I think, is that whole unprocessed seeds sitting in a commercial spice cabinet can retain life.
It suggests a powerful, unexpected potential for growth and discovery hidden in the most mundane, everyday places. Just waiting for someone to ask the right questions and apply a little bit of systematic effort.
That shift in perception is pretty profound. When you buy ingredients, you assume their life cycle is ending, right? They're ready for consumption. But in this case, these seeds were just waiting for the right conditions to begin a whole new life cycle.
Which leads to our final provocative thought for you to mull over. If this little mix of tiny whole seeds can successfully transform a garden, what other everyday unprocessed and seemingly inert ingredients in your kitchen that you currently only think of as food are secretly waiting to spring to life, ready to become your next great systematic project?
Thank you for joining us on this deep dive. We'll catch you next time.